Welcome back. We're doing Algebra 2's Chapter 5, Sections 8 and 9 notes. I believe this is Part 4 of the notes. We're looking at Example 1 from the Section 9 part. This is the top of page 3 in the notes. We're meant to write a cubic function given information from the graph. Now, they gave you a nice graph over here on the right, and on the left, step-by-step process on how to go ahead and write it. We are given 1, excuse me, that's no good. 1, 2, 3 x-intercepts, and using that x-intercept information, we can write the factored form of the polynomial function. X plus 2 is a factor from the 0 at negative 2. Then we have x plus 1 as a factor. That comes from the 0 at negative 1. And then finally, x minus 2 as a factor from the 0 at 2. And it seems like we're done and everybody's happy. But you need to acknowledge that you can have any constant number in front that you want. So we call it an a. We did this before in Chapter 4 when we did quadratics, and we were writing functions off of a graph that were quadratics, the parabolas. So just knowing the x-intercepts isn't quite enough information to actually know everything. However, we're also given one additional point, which is 0, negative 8. And so we can use that information to go ahead and put that in. Now that means when x is 0, the y value is negative 8. So 0 plus 2 times 0 plus 1 times 0 minus 2. All of this goes ahead and is information that we have using our additional point. If we go ahead and put all information together, we have 2 times 1 times negative 2, and that's negative 4. So negative 8 equals negative 4a, so a equals 2. That means the function is f of x equals 2 times x plus 2 times x plus 1 times x minus 2. There we have it. We have our function written. But just to be sure, to feel like we know what's going on, there's this check. The check is optional. I'm going to go ahead and rewrite it really fast because of the way I do this. I'm unable to keep it all on the screen at once. You already have this written on your paper. But they're saying, go ahead and look at the end behavior. If you tell me it's really a third degree polynomial, which means an odd degree polynomial, and the leading coefficient is positive, right? We're talking about a number that is greater than 0. That means f of x has to go to negative infinity as x goes to negative infinity, and f of x has to go to positive infinity as x goes to positive infinity. I personally don't care for the way they write this out, but the idea of saying, go back, look at your polynomial, third degree, positive number in front, make sure the arrows go the right way, that is a good way of checking what you're doing. That's an important thing. We've finished example 1 off of the notes. This is section 5.9. Thank you.